Hi, everybody. I'm sure other people will be popping in, but if anyone has a question, they can feel free to start, or we can just wait if you guys are just waiting on someone else to ask a question. But as soon as you hop on, feel free to ask a question if you've got one.
Hi, I just had a question. I did the like the extra K practice problems, and I was wondering if there were solutions up for that.
There are. So if you look at that and go to the second sheet, it's attached to it. So that sheet
Oh,
had 2 pages. So the first sheet was the blank and the second was the solutions.
okay, thank you.
Yeah, so it should be right on there.
Wait, sorry, which one was it? Oh, my bad. Go ahead.
I posted on, so I think Kira, who's in A Block, had asked me to put up some more domain and range problems with that are like the quote K problems. So I put those on Canvas, and it is just one document. Like the first page
Okay, perfect.
blank and the second has the solutions.
For the like 9C on the review,
Yeah,
I was wondering if you could go over like the process on like how to find a function with the given domain and range.
sure. Let me can you let's see. Tell me if you can see that. Can you see
Yeah,
that?
I can see it.
Okay,
Yes.
great. All right. So let's go to 9C. Okay. So here it is. So remember, I think it was on one of the quizzes, maybe I gave a domain. I think it was maybe I only gave a domain, and I said find a function that has this domain. I think it was the first quiz. So one tip for, like, we always start with the domain. One tip is if like a huge part of the domain is being cut off, then think a square root. If it's just one value or two values or a discrete number of values that's being cut off, then I think the denominator where the denominator equals 0. So again, I start with the domain and I realize I'm only dealing with 7/3 to infinity. So that must mean I have something under a square root. So there's multiple things you could put to make under, or the multiple ways you could show it to make under the square root end up being 7/3 to infinity. So I always start there. So I think, okay, some people said do x minus 7/3. Totally fine. You could do it like that. I think I did 3x minus 7 just to not have a fraction under the square root. But if you wanted to do this, do you see how that would have a domain of 7/3 to infinity?
Yeah, I do.
Yeah, so start there. Now I think, okay, that takes care of the domain. Now for the range, right now, the range of this would be 0 to infinity, which of course is not what I want. First of all, I want mostly negatives. So I want negative infinity. So we can take care of that by putting a negative in front. Then it would be negative infinity to 0. And then I think, okay, I don't want to go all the way to 0. How can I instead just go to -3? So if I just subtract 3 from that, that would get negative infinity to -3.
Okay, thank you.
Yeah, so I think that always start with the domain like everything else, and think if there's a huge part of the domain being cut off, think square root versus just specific values. Then you could think a denominator.
And then if it's like only a small part, would it be like a fraction, like as a
Yeah, so
function?
yeah, so say instead, like what I mean by that is say instead I said this was the domain. Like I'm just cutting off a specific value. Then I would think, okay, so I could, in this case, that I could have some number over if it can't be 7/3. I mean, I guess I could have x minus 7/3, or I could have 3x minus 7 in the bottom. But then the range would have to be totally different. So I wouldn't have this type of range if that was the domain.
Okay, yeah.
Can I ask you a question about one of the problems from the quiz?
Yeah.
So for like all of the three versions for like number one,
yeah.
Yeah, so for number one, you had like a problem where like 1C specifically where you like find the domain and range of like the composition of the functions. And I was just wondering like if you could kind of go over that a little bit.
Yeah. Yeah, sure. So like one of those domains of a composition, right?
Yeah.
Okay, so let me make one up. Okay. So let's say I have let's say f of x is 1 over hopefully this turns out okay, 1 over 2 minus x. And then I have g of x being, actually, let's make it 1 minus 2x squared. And then I'll have g of x is equal to, let's do the square root of, yeah, let's do square root of 1 minus x, something like that. And if I said find f of g of x and its domain. Okay, so let's do this. So I always, every single time when I'm finding, especially if I know I have to find the domain, and I can say range, find its domain and range. I always start by actually substituting in what that inner function is. And at this stage, always, no matter what the function is, I make note of what the domain of that inner function is. Because in this case, it's definitely not all real. So what's the domain of that inner function? So I set the inside has to be positive. So it means that the domain of the, right away, I'm limited to x values that are less than or equal to 1.
Yeah.
Okay, so that means that no matter what happens to the end result, I'm restricted to this because it has to pass through the inner function. Okay, so then I put that inner function in for x. So it's 2 minus the square root of 1 minus x, which is going to be squared. And I tend to, I mean, I like to simplify it because it's easier to find the range of the final result by looking at the simplified version. And the square root of something squared, they undo each other, the square root and the square. So it's 2 minus, and I just put the parentheses. So it's going to be 2 over 2 minus 1 is 1, and then plus x. And so from that end result, what else can x be?
It can't be -1.
Right, x cannot be -1. Okay, so putting both of these together, because it has to meet both these conditions, that gives me my new domain. My new domain is going to be -infinity. I know it can't be -1, but then I'm all good until I get to 1.
Okay, got it.
So that's the domain. So again, always the inner function, and I do that right away before I even put it into the outer function, and then I look at the end result. And now I have to keep that in mind when I do the range. So either when you do the range, either keep in mind the unsimplified version, or I just keep in mind this domain, knowing the fact that the highest I'm putting into here is 1 in the bottom for x. Okay, so for the range, I've got 2 on top, and then I have on the denominator, if I can put in for x everything from -infinity to, I can't put -1, but we'll take that into account in a second. If I can put everything up to 1 in, what's the highest that the denominator could be?
Like negative, or the highest it could be is 2.
2, right. So the denominator is going to range from -infinity all the way to 2, except I just want to make note of the fact that I can never divide by 0. And then this is where I do my analysis. I do each piece one by one. So I think, okay, 2 divided by -infinity. It's definitely going to be negative, but it's going to be a negative tiny. So getting really close to 0 on the negative side. Then 2 over a very tiny negative is going to approach -infinity. And then on the positive side, 2 over a tiny positive will get huge. and then 2 over 2, the closest it will get to 0 will be 1 on that positive side.
Okay, got it. That makes sense.
Yeah, so it's just it's a little trickier and more involved with compositions, because some people tended, because if this were just, if I didn't even have an inner function and I was just looking at 2 over 1 plus x, the range would just be everything but 0. I mean, because the denominator can take on all values except for 0, which means I'm going to achieve all values in the fraction except for 0. But all these were a little more complicated because it had to go through an inner function first.
I have a question.
Yeah.
For 1.10b, do you mind walking through number 3 again? Or like number 3D?
Yes, I will do that. So I'm going to go, let me just open, give me a second to open it up here. 110b, right?
Yes.
Okay. That was where there was a bunch of graphs.
Yeah.
Okay, 110b. Okay. Okay, tell me which number again? This
3D. Yeah.
3D, right?
Yeah.
Okay. Yeah, so I'm not going to have a ton of graphing on there, and especially it just will get super complicated in one. So when you're going to do graphs, I'll just give you you're just going to do a transformation per graph. So there, because my God, I don't want to read like 4 different transformations for you people on one axis. So
Okay.
for a little graph, I'm going to you'll just be doing one. So given that, I might do this in 2 stages. So meaning, first, I always tend to list out what the transformations are. So the transformation in X is, remember, or in the domain, means reverse order of operations. So what would I do to each X value?
Like for which
We're doing
reverse,
right?
reverse.
Yeah, so what would I, in this specific problem, d of X, what do you do to each X value?
Oh, subtract 2. So
Yeah.
left 2.
So left 2 for each X value. And then for each Y value, I'm going to go down 4. And I'm going to do that first, and then I'll deal with the absolute value in the Y. So let's just go each point. I would go left 2 and, whoops, want to do down 4 at the same time. So each X value, I would go left 2, or each point rather, and then down 4. So left 2 and then down 4 would leave me at 5. So left 2, down 4 would leave me at 4. So given I'm doing this quickly, anyone let me know if I'm making a mistake here. Okay, so left 2 and then down 4 would give me at 1. 5, yeah. Left 2, down 4 would give me at 0. And then the last one is left 2 and down 4. So, okay, so just drawing this before I deal with the absolute value, right? That's what I've got. Now, the absolute value in Y means that anything Y value that's 0 or positive, there's absolutely no change. So this is staying exactly the same, this part. So I always mark that. And then anything that's negative Y becomes positive. So this -6 is now going to come up to a +6. Where is 6 here? And so it's going to look like that.
Okay. Wait, and sorry, one more thing. What's the difference between B of X and C of X?
Oh, okay. It's the order you do things, right? So say if we say we take this point here, which is an X value of 6. So if I look at B, if I want to see where that 6 goes, the first thing I do is this just helps me with the order of operations, or like what I'm going to do. This means first thing I'm doing is an absolute value transformation, Whereas in part C, the first thing you would do is shift the whole graph left 3.
Okay. Yeah.
So in part B, I'm first going to mirror and then shift left 3. Whereas in part C, I'm going to shift the graph left 3 and then mirror it.
Okay, that makes sense. Thank you.
So if you're unsure about the order of things, like pick a particular point just to see, oh, okay, in this point, I'm doing the absolute value thing first, which is the mirroring. Then I'm doing left 3, where it's the
Yeah.
reverse here. Left 3, then you're going to mirror or do the absolute value thing.
Okay, thank you.
Can you review, like, I think on the review packet number 12, and like in general, like reverse transformations, like where you have the transformation and you want to get back to f of x, or you want to get back.
Yeah, so
Mhm.
that 12 is actually, I know the wording of 12 is weird. The wording of 12 is actually tell me the steps to go from the original to this transformed. That's actually what it's saying. And if I could write it properly, that would be nice. 12 is actually saying tell me the steps to go from f of x to this transformed. But so that I always write down that first. So let's do that first. And then let's walk through, what if I asked you to do the reverse? What would the steps be? So in this case, if you start with the original function and you want to go to the transformed, and I would pick, if you're unsure, I would pick a random. So this is all in here is all the domain effector. So if you're unsure of the order of doing things, pick like a random number. Say you wanted to do f of 1, which means you're going to set the everything inside the function equal to that number. And that'll help you figure out the order. So what would be the first thing I would do in this case? Because you always want to start with the domain transformations.
Like divide by negative.
Yeah, divide by -1, right, which means flip over y-axis, because all the x values are going to change sign. So you're going to flip over the y-axis, the graph, or divide by -1. You can write that as well. And so if I do that, then what do I do next?
You subtract 7 and then divide by 2.
Yep, so left 7 and divide by 2, right? Divide x values by 2. Okay, so again, always do the domain first. Then what would you do to all the range values?
Shift up by 4.
Up 4, right, perfect. So if I wanted to then go the reverse direction, so say the question had been, all right, you've got this, and I want to go back to the function. And by the way, if this is the question, I personally always go through this first, just because this is what I know. So it's easier for me to list that and then go backwards. So for the domain, we're doing the exact opposite. We're undoing it. So what would be the first thing I would do with the x values?
Divide by 2.
Well, careful. What's the opposite of dividing by 2?
Oh, multiply by 2.
Yeah, exactly. Multiply by 2. Right. So
Oh,
think like inverse, doing the opposite. Multiply by 2. Then what?
Add 7.
Right. So write 7 or add 7. Either one's acceptable. And 3.
You multiply by negative.
Yeah, multiply by -1, which is the same as dividing, right? So multiply by -1 or flip over the y-axis. Multiply by -1. Okay, and then for the range, what would I do?
You subtract 4.
Yeah, subtract 4 or down 4, right? So notice when you're going from the transformed back to the original, it's the exact opposite, meaning the domain actually follows the order of operations. Like I think of the order of operations here would be multiply by -1. Starting with x, I'd multiply by 2, add 7, then multiply by -1. And then the range would be reverse order of operations. So it exactly flips what you would do.
But would the question be like, list the steps, or would it be like,
It could be list the
After-
steps, or it could be like the problems we've done in the past. Here's a graph of this transformed function. Go back to the original. Or
So
I
how-
could, oh, sorry, go ahead.
oh, if you were to go back to the original and like graph it, what would you do?
You do these exact steps for each point that we just listed.
Like in order, 1, 2, 3?
Yes,
Okay.
exactly. First multiply by 2, then write 7, then multiply by -1. Right. You do those exact steps. Yeah.
Okay, thank you.
For number 20 of the review packet, I'm like really confused on like where to start. I was wondering if you could walk me through like the process to solve it.
Oh, yeah. Okay. So this is a type of problem. This is just kind of a funky working with functions. I too, if I looked at this problem, I would have no idea where it's going to go. So, but I do know, and we'll, as the year goes, we'll do more of these types. Unfortunately, as you get higher in math, often you're going to see a problem and you'll be like, okay, I have no idea how this is going to end up. You just have to do something. So we know the fact that f of -3 is 4. Okay, so what does that mean? It means if I plug in -3 for x, so let's do that. So if I plug in -3 for x, -3 to the 4th is 81. So I've got 81a minus -3 squared is 9. So minus 9b. 2 times -3 is -6. Plus 1 equals, and I know this equals 4 because that's what I've told you. When you plug in -3, you get 4. Yeah, the bummer is I have 2 variables, which isn't super helpful right now. But let's just do what we can here. So we have 81a minus 9b equals 9. So that's one equation. Again, not really going anywhere right now, but I want to know what f of 3 is. So let's do that. So if I plug in 3 for x, I've got 81a minus 9b plus 6 plus 1. And I want to know what the heck that equals. So one thing to notice, and again, this is kind of tricky that I wouldn't put on a test, but it is a cool thing to get. What I do want to, sometimes I'll put on review stuff, things that are a little bit harder than I'd put on a test, just to get you used to kind of doing more challenging things. Notice this, 81a minus 9b. Do we know what the heck that is?
No.
Well, look one step above.
Oh, it equals 9.
Yeah, exactly. So there had to be something that first equation was useful for. And that was the fact that, oh, there we go. That's 9. So this whole piece is 9. So f of 3 is just going to be 9 plus 6 plus 1, which is 16.
Oh, okay.
Again,
makes
that's
a lot more
trickier
sense.
than I'd give you. It's good for a review packet, but it's a little trickier not for a test.
Yeah. Okay.
Can you do 14a and b where you're like graphing the even and odd functions on the yellow packet?
Oh yeah, sure. So this is on the same review packet, right?
Yeah.
Okay. Yes. So this is the fact that so this is all about symmetry. So what is in the symmetry of an even function?
It's y-axis.
Yeah, right. Remember, it means that when I plug in something opposite in sign, it has the same value as its positive counterpart. So I know that looking at this graph, I know that, for example, f of, let's see, make it a little bigger so we can all see, or maybe so I with my terrible eyes can see. I know that f of, this is -1. I know that f of -1 is 1. But so if it's even, what other point do I know?
F of 1.
F of 1 is 1, right? And if f of -2 is 0, like this point here, I know f of 2 is 0. So the graph should be, if I fold it over the y-axis, it should totally line up, like a parabola lines up if you fold it over the y-axis, like the parabola y equals x squared.
Okay, so then b, would it just be over the origin since it's odd?
Yeah, exactly. So in this case, if -1 goes to 1, then 1 must go to -1. So it must go down here. And so it's going to look something like that. So if I flipped it over both axes, it would line up. Yeah, the origin symmetry.
Okay, thank you. Ms. Jensen, I have a question on 1.8 transformations.
1.8?
Yeah.
Yeah. Okay, let me open that. Was that the original transformation packet?
Yeah, I think so.
All right, I'll just open 1.8. Okay, which one here?
So I'm a little confused on number 9 because I thought that all of the or I'm confused why all of the transformations are vertically stretched and like smushed instead of horizontally because there's no like parentheses around the x values.
Oh, okay. So is this in the table?
Yeah.
Okay, yeah. So what you want to think of, so this is the parent graph here, right? That you're comparing it to. And when you do a transformation in X, like say I were to like horizontally, let's look at this one in particular. Say it was a horizontal stretch or smush. So that would mean I would be doing f of 1/3 of x, which how would that look? That would look like 1/3 x all cubed. So because you're not seeing parentheses raised to a power or things happening in the absolute value or things happening in the squared, everything's in front of that. So that means it has to be a vertical versus a horizontal. Horizontal means instead of putting in x into the parent graph, you're putting in a multiple of x. So I guess you could say, I mean, one exception is with g of x. You could argue it also could be a horizontal because I could have done g of x could have been f of 2x. So where x is, I could put 2x squared, which would result in 4x squared. So I could see for g of x, you could argue either. But if it's in front, if it's not within the x of the parent function, then it's involving the y versus the x.
Okay, that makes sense. Thank you.
Yeah. So I always look at what the parent function is and see, okay, how is it changing? Am I putting something in for x and changing it, or is it something outside of that?
If it was within the parentheses, would it be in the x?
Yeah, it would literally, if I had done it, if I wanted you to hone in on it being a horizontal transformation, I literally would have written something like that. Or I would have written for g of x in this problem, I would have said something like that in the absolute.
Okay, got it.
For quiz 2 or 3, can you help me with b of x and like saying a restriction?
Yes, which quiz are we talking about? Which one? Which version?
2 or 3, they have the same problem.
Oh yeah, I think I did put that same problem on once. Okay, give me a second. I'm gonna open the quiz versions. Something like this one?
Yeah, the problem B.
Okay, so first, Noah, tell me, how do you prefer to find an inverse in general? Do you prefer to undo if there's only one x, or are you doing the method where you switch x and y?
I undo if there's only one x.
Okay, perfect. Okay, so let's do that method then. So first I list out what have I done for x. For x, I've multiplied by 2, and then I subtract 1, then I square, then I add 3, and then I do the square root, right?
Yeah.
Okay, so to undo this, I'm first, the opposite of square root is squaring, subtracting 3. This is the one you always have to pay attention to, because opposite of squaring could be the positive square root or the negative. So then I look to the restriction to figure out which it is. So
Negative.
which would it be? The negative, right? Because this will be the range of my inverse. So if the range of my inverse is negative infinity to 1/2, it better be the negative square root. Yeah, so negative square root x squared minus 3, add 1, and then divide by 2, right?
Mhm.
Okay, so that's my inverse. And just I want you all to be good at then always looking at an inverse and asking yourself, is that invertible? And
Uh,
what do you think?
it's not because there's a square.
Right,
And
exactly. So
for,
go ahead.
like for the restriction, it would be like for x is like less than 0, right?
So careful. I
Or less than or
think,
equal.
go ahead, sorry.
Wouldn't it be less than or equal to 0?
Well, how are you getting 0?
Because then 0 comes out of the squared function. Actually, no, it has to be greater than or equal to 0. Or it has to be greater than or equal to like √3. What? It's
Right.
√3, right?
It's √3, right? And so how you get the restriction, to get the restriction, I honestly don't even pay attention to this inverse because I know the restriction has to match the range of the original function. So I like abandon the inverse to find the restriction. I go back to the original function, which is this. And in order for a domain, for it to be an inverse, domain and range flip. So what is the range of this inverse? And you're right. The smallest this piece could be is 0, right? And then it's
Mhm.
going to get huge. So the smallest coming out of the square root would be what?
√3.
√3, and then big. So you're going to say for x greater than or equal to √3, right? Because the range of this original function is √3 to infinity.
So just for find domain restrictions, just ignore your new equation, just find the range of the old one.
Yes, exactly.
Thank you.
For the practice questions that you put up in class today,
Yeah.
for E, like y equals 3 times absolute value f of 2x minus 1,
Yes,
is the range possible?
it is. Because
Okay.
so let's go through that because always do domain first. So what was the original domain? I think it was negative.
-3 to 2 and
And-
inclusive.
And what was the original range?
-6 to 4.
Okay. All right. That's helpful. All right. So always do the domain first. And so if this is inside the function, that's the only thing that's going to go between the extremes of the domain, right?
Yeah.
And which means I'm going to shift right 1. So add 1 and then divide by 2. So the domain. So notice here, wait, add 1. Oh, sorry, -2. I forgot to add 1 there. That didn't look right. And divide by 2. So -1, 2, 3 halves. So have I cut off any of the graph here?
No.
It's just literally the whole graph was shifted right and then it was horizontally smushed. So I haven't lost any of my graphs. So what's coming out of this function before I do the absolute value in y is still going to be -6 to 4. And absolute value in y means all y values that are 0 or positive are not going to change. But any y values that are negative now become positive. So what is now the smallest y value if I take the absolute value of the y's?
0.
Right. And now what's the new high?
12. Right,
Okay.
because
Oh,
4, but after, like before the transformation, 4.
Well, don't multiply by 3 yet. Let's just do the absolute value between -6 and 4. Like the low would be 0 there. What would be the high now? So let me give you,
6?
yeah, it'd be 6, right? So, and the reason that's the case is and I think I did this, but I know you had to leave early our class, but one thing that I showed in class is like, sometimes I agree, when I was a student, like this was confusing to me. So I would say, okay, the graph is, if original graph had a range of like -6, I'm just going to draw a sample graph for myself just to see. And the high was 4. Then doing the absolute value of that means that this stays exactly the same. And then this -6 comes up as +6. So that's how my new graph would look like. So now looking at this purple piece, the range would be 0 to 6. And now all I have to do, so that's the absolute value piece. And then I just am going to multiply it by 3. So instead of your high, as you said, being 12, what's your new high?
18.
18, right. Exactly right. Yes.
Wait, so when
Okay.
there's a absolute value outside of the function, or outside of the like inner function, I guess, is that when like there is no like range like issues, like you can still have a possible range?
Yeah, you can still have a possible, yeah, there's, right. So absolute value outside is not impacting whether it's a possible range. You can do it.
Okay.
Hi, could you go over 19 on the review packet?
Sure.
Thanks.
Am I on the review? No, I'm not on the review packet. Okay, 19 on the review packet. Okay. Oh yeah, this is kind of a weird one. Okay, so I'm defining this new function that if two numbers are multiplied together, then so if I'm multiplying two numbers, so f of two numbers multiplied, that I'm saying is equal to f of one of the numbers plus f of the other number. So I'm just defining this weird new function. So if I'm asking you to find f of 12, and I am giving you some information that may be helpful to us to find f of 12, give me let's find two factors of 12. What are two numbers that multiply to 12?
3 and 4.
Yeah. So this is f of 3 times 4. That's equal to 12. Well, according to my definition of my new function here, this is f of 3 plus f of 4. The good news is I know what f of 3 is. What's f of 3?
It's 10.
10. I don't know what f of 4 is, but let's find out what f of 4, because what two things can I multiply to get 4?
2 and 2.
Yeah, exactly. So I can apply this rule again. F of 4 is f of 2 times 2. So this is just f of 2 plus f of 2. And I actually know what f of 2 is. It's 7 plus 7. So f of 4 then is going to be 14. So then I can just put that back here. So 10 plus 14 is going to give me what?
24.
Yeah. So again,
Okay.
it's just kind of yeah, we haven't done it before, but it was something, just like kind of playing with functions. And again, some of the 19 I would put in the category like 20 is something that just kind of building your guys' muscle to do something different than what we've done before.
So do you think there's going to be like one of these specifically on the test? Like one of these like weird addition ones with functions?
No.
All right. Okay. Thanks.
Later in the year. So I'm kind of warming you up for kind of later in the year. We'll get more and more like applying stuff, but 19 and 20 are just trying to show you that you know some function stuff. So which means actually you could do a lot more than maybe what you think.
Okay. Thanks.
Yeah. And if you're wondering about 21, anyone, I don't know why I had h of x in there. I think at some point I had a part C or something that involved h of x, but there is no h of x involved in 21 and what I'm asking you. So I don't know why it's floating there, but again, I think I had another part that I had eliminated.
Do you have a solutions sheet for the practice problems we did in class today?
I don't know, like the ones that, no, I didn't put up a solutions sheet. But if someone has solutions that they copied down, I'm happy to put it up on Canvas. I actually don't even have what the problems I put up. I didn't bring them home.
Okay.
So I didn't, yeah, because you left early. So maybe if someone could give you those, that would be nice of them.
Okay. I can ask around.
Okay, sorry about that. I do not have a solution sheet because some
That's
of that,
okay.
but I gave every class about the same, but some were slightly different. So I don't think, because the last two I kind of made up on the fly for each class. They were very similar, but there wasn't just one problem set.
Yeah, makes sense.
Can you go over 15 E and F? Like I'm kind of confused. Like,
Oh yeah,
kind of
this
confused.
is the odd and even, right?
Yeah.
Okay, yeah. So plug in negative X, right? And that's the first step. Okay, so looking at this, it definitely isn't the same as the original, right?
Yeah.
And say you weren't convinced of that, right? Maybe someone, so say, let me write this a different way. So if I take out, because people, I know absolute value trips people up. So let's say out of the top, I rewrite it by taking out a -1.
Mm-hmm.
So say I rewrite it like that. Another, this is an absolute value. Another way to think about this is its absolute value of -1 times x plus 1. And the absolute value of -1 would just be what?
1.
1. So I could rewrite by plugging in -x. I could say it equals this, the absolute value of x plus 1 over -x. So is that equal to the original?
No.
No, it's not equal to e of x. So then so it's not even. So the question is it equal to negative e of x? So negative e of x means either I distribute a negative to the top part or I distribute it to the bottom. If I do that, so if I put a negative in front here, or if I put a negative in the denominator, am I going to get this e to the negative x?
No.
No, you're not. So it's a neither.
Okay. Wait, can you also go over f of x?
Yeah, I'm going to go over f of x in just 1 second, but I want to make sure people understand that. So the reason it gets thrown off that it's a neither here is the fact that you have not just an absolute value of x in the top. You have this absolute value of x minus 1, which makes that top really neither, and then that results in the denominator not even mattering, because if the top's neither, the whole thing's going to be neither.
How come you distributed the negative to the negative, the whole numerator instead of just like the x? Because aren't we supposed to like plug in negative x basically? So why did you do it to the -1 as well?
Did I do it? I don't think I did it to the -1.
I thought you put a negative sign in front of both. Like,
oh yeah, when I put a negative sign in the front here, yeah, I can't really even distribute it inside because a negative would never even come out of the absolute value. So I just have to leave it in front there.
Oh, okay.
F, all right, let's do F. F is a little different. So F, if I plug in negative x, I've got why am I writing it like that? Inside the absolute value in the numerator is -x squared minus 3. And then I've got this -x, right? So it equals, notice, is the numerator changing? When I plugged in -x, did the numerator change at all? No.
Yeah.
If the numerator didn't change, I can think, okay, in the numerator, it looks like I have an even function. And then the denominator, did that change?
Yeah.
Yes. It totally changed, right? So it's definitely not the original. So it's not even. But is it negative the function? Remember, negative a fraction means either you put a negative with the numerator or the denominator. Since my denominator changed in my original, I think of putting a negative to the denominator. And isn't that equal to f of negative x.
Oh, okay, yeah.
Yeah. So this would be odd. And again, some people think about, okay, when I put in negative x, I end up, oh, this is an even function over an odd function. And an even divided by an odd, just like an even times an odd, is going to be an odd.
Wait, can you go over again how you like determine how f of x is odd but e of x is neither? Even though they
Yes.
both have like negative denominators?
Yeah, because look at f of x. When I put in negative x for x, did the numerator change at all?
No, because it's
No.
squared.
Because it's squared. Exactly. But if in e of x, part of the numerator changed, right? This part of the, oh, meant to have my little highlighter there. This part of the numerator changed, but did the -1 change?
No.
No. So so that means the numerator is a neither, because remember, if functions are even, the constant doesn't matter, because an even function, when you put in a negative x, nothing changes. But if it's odd, everything has to change. And in the top, that negative x, that x became a negative x, but that -1 remained exactly the same. So that top ended up being neither. And again, whenever you have a neither divided by anything, it's going to be neither.
Okay, thank you.
Yeah.
Can you go over 7C on the review?
Sure. 7C. No. Oh, yeah. So this is the type of problem, the transformation problem, where you have a point. Where does the new point go? Where does the point go given the new transformation? Okay. So sometimes I just find it helpful to write it in coordinate form. So I've got -1, 4. And then notice that here, I'm not transforming G. What am I transforming? What is it?
The inverse.
Yes, the inverse. So let's first deal with, if -1, 4 is the point on G, what's the point on G inverse? Oh, yeah.
For -1.
Yes, exactly. So first I'm going to write what the point is. So the point is 4, -1. So that's the point I'm dealing with. So for G inverse, that's my point. Okay. So now let's deal with where does the point go? So I set the inside is my domain effector. So I'm going to set that equal to the x value I know of 4 to figure out what am I putting in for x now, so that I'm evaluating G inverse of 4. So that means I'm going to subtract 5, so -1, and divide by -2. So the new x coordinate here would be 1/2. Does that make sense, Malia?
Yeah.
Okay. So now with the y value, I know coming out of my inverse, this should be -1. So I've got 3 times -1 plus 1. So what would that be?
-3 plus 1.
Yep.
So -2.
Yes. So that's
Okay.
that's the new point.
Okay, great. Thanks.
Yeah. So deal with the inverse first. What's that new point just if it was the inverse, and then do the transformation to each piece.
I have practice problems where you have to like find a domain, but like x is like the domain range, but x like under, like it's 4 over x or something like that.
Oh, you mean where the denominator has the x?
Oh yeah.
Okay, sure. Let me give you guys a couple here. Okay, so find domain and range. Let's do Let's do. Actually, let me do this. 5 minus x squared. Do that one. And let's do. Think about those.
Thank you.
Yeah, those are the ones I want. Yeah. Sorry, it took me a minute to think about that. So if anyone has a pressing question while people work on that, you can ask me, or if people all just want to work on this, that's fine too.
What's the answer to the second one for the range?
All right. Have you done the first two?
Yeah.
All right. Are people ready for the answers? What do we think? Do you want one more minute, or are you guys ready? Let's do one more minute, and then I'll give you the answers. So sit tight for one more minute now, and then I'll quickly go through what the answers are. All right, let's look at the first one. What did people get for the domain of the first one? When would the denominator be 0?
I got √5.
I got plus or minus √5.
Yeah, so don't forget when you're squaring, it couldn't be positive or negative √5. So that means, which is annoying, I agree, because it means a lengthy writing of this out, but important to do so. To root 5 to infinity. So there's two values it could not be. It couldn't be the positive root 5 or the negative root 5. So just remember when you're solving for something squared, by taking the square root, it's plus or minus. Okay, so now with the range, I think, okay, I've got this -3. What's the range of the denominator?
Negative infinity to 5, but inclusive of 5.
No zero, no zero.
And
no-
including 0.
And no zero, exactly. Because it's in the denominator, it can't be 0. And this is when I literally just systematically go one by one, going through all 4 of these scenarios. So -3 over negative huge, a negative over negative is positive. So what is that going to get really close to?
0.
0 on the positive side. Yes. -3 over a tiny negative will get
On the positive side.
infinity on the positive side. Right. -3 over the tiny positive. What will that get towards?
Negative infinity.
Yep. And then closest it will get towards 0 on that negative side is -3 over 5. So -3/5 with the union in between. Yeah, so with the range, I always do, okay, what's changing? The denominator. So let me just find the range of the denominator. I just have to remember it can't be 0. And then I go through one by one that analysis. Okay, how's 1? Is that all right? Take that as a yes. All right. So for 2, again, I go about seeing the denominator can't be 0. Well, can the denominator in this case ever be 0? No. There's no way it's never, ever going to be 0. So that, yay, that means the domain's everything. There's nothing that would make that denominator 0 because it's always going to be 0 or positive plus 2. Okay, so then I go to the range of the denominator. What is the range of that denominator?
2 to infinity.
Right. 2 to infinity. 0 is not even in there. Remember, we can't divide by 0 anyway, in this case. Okay. And so then I go about, what's 4 divided by 2?
2.
2. What's 4 divided by 0?
Really close to 0 on the positive side.
Yeah, 4 divided by infinity, not 4 divided by 0. Yes, really close to 0 on the positive side. And then we've got 4 divided by 2 is 2 with a bracket. Yes. Right. And I feel like those are the two kind of that sometimes the 2 types you would kind of encounter with the denominators ranging and the numerator being just a number.
Can you give a few practice problems where like the domain has like an absolute value or like the range has like an absolute value?
The range, wait, is this practice problems for domain and range or?
Like finding the domain and range.
Okay, so let's do another. So let's h of x equals, yeah, let me do 2 types. Let's do -3 x plus 1 minus 2. Or let's do, say r of x equals, something like that. So I wouldn't do anything kind of more complicated than this because we're actually going to do a ton with absolute value in the next unit. So I I can only go so far into absolute value stuff, but you guys could do something like these too. All right, for time's sake, I'm going to go over this, even though I'm sure some people aren't done. So let's look at 3. Is there any restriction on what I can put in for X?
No.
Yeah, there's no restriction on what you can in general put in an absolute value. It's not like a square root. There's nothing in a denominator in number 3, so all reals. But coming out of an absolute value, the smallest in this case would be 0. Then it could be huge. And so then I'm going to follow that order of operations. So it'd be -infinity to 0. And then -2. So the range would be -infinity to -2 for that h of x. Okay. 4 is more interesting. Because even though I can put anything in the absolute value in general in x, I do have a denominator here. So I can't have the absolute value of x minus 1 minus 2 cannot be 0. So what values of x would make that 2? So what?
-1 or 3.
Yeah, x cannot be -1, right? Because absolute value of -2 is 2. So that's a problem. And 3 would be the same, right? So there's 2 things x could not be there. So you'd have domain is -infinity to -1, -1 to 3, and then 3 to infinity. Perfect. Okay. So then that brings me to the range. When I think of coming out of an absolute value, the smallest is 0, and then it can be huge. And then I'm going to subtract 2 from that. So I've got 4 over, I'm going to have -2 to infinity, but because it's in the denominator, what can't I divide by?
0.
0, right. So I'm going to write it like this. The range of the denominator, again, is -2 to infinity, but I can't divide by 0. So now doing that out, 4 divided by -2 would be -2. 4 divided by a tiny negative would be -infinity. So that's the negative side. And from the positive side, 4 divided by a tiny positive is going to be huge. 4 divided by a huge number is really close to 0. So that would be my range.
Are we out of time, or could I ask for some more practice problems?
Say that again?
Are we out of time, or can I ask about another type of practice problem? Or...
I can give you a practice problem and then I can post an answer, but I'm going to have to tap off here. But I can, but if you want me to give you a practice problem, I certainly could do that. And then I could just post an answer.
Yeah. Could you give me a practice problem about when you find the domain and range, but with restrictions?
Domain and range, like find an inverse?
Yeah, finding the inverse, my bad, with restrictions and stuff.
Oh, yeah. Okay, so got it. Yes. So sure, let me give you a problem. So find the inverse All right, so let's do f of x equals. Let's do 2 minus 3 square root. I'm trying to make this one interesting. Let's do 25 minus x squared for x is let's do greater than or equal to -5, but less than 0. So that's your restriction. Yeah, that's what I want. Yes.
Thank you.
So yeah, greater than or equal to -5, but less than or equal to 0. Okay, so I'll trying to think. Yeah, I'm gonna, where will I post? Yeah, I'll post this on Canvas and I'll just write in module 1 inverse with a restriction problem. How about that? And I'll give you guys the answer for anyone who wants it. Okay?
Okay, thank you.
All right, guys, I'm there during tutorial tomorrow. So if any other questions come up, just come on by.
Thank you.
Bye, everybody.
Thank you.
Thank you.
Yeah.
Bye.